so we've just tried to get to this n here, right? This unknown n, this unknown exponent, using logarithms to get there. Now this is a quantity I can factor out. N is equal to the natural log of v2 over v1 divided by the natural log of p1 over p2. By the way, yes, I know there are some simplifications I can employ here. I don't care. These are numbers. These are numbers. This becomes a number that divided by some other number, and I can get a value here. Okay, so let us go find these properties. Again, I've got water, and I know P1 and T1. I've got 2 megapascals and 800 degrees C. Okay, now I know you're probably not going to be able to see this very well. Again, if we're in class, this is where I say, all right, pull out your books, and I will wait until you guys give me an answer you all agree on, and I literally will just wait until the students give me numbers and we get some agreement. Because at this point in the semester, you're starting, some people are really taking me seriously and tried to practice learning how to use these property tables. Some of you guys are like, Steve, that's silly. I'm not going to do property tables 100 times. Well, you are, or you're probably not going to pass. It's up to you. So let's go see. I know at 2 megapascals and 800 degrees C. So I've got a row down here for 800 degrees C. So again, you should be doing this as you follow along. I'm getting here 0.24674. 0.24674. All right. Now, how do I know that? And again, we said go through the process of say, all right, what is the phase? We know at 2 megapascals, water is going to boil at 2 megapascals at 212 degrees Celsius. That's my saturated temperature, which matches these rows in the top row. You could go to the saturated tables and find the same information. But water boils at 212 Celsius at 2 megapascals. We're down here at 800, so that puts us in the superheated phase, and we just go pull that value. Okay. The other phase is let's see, I can see, if you look back, the other one is 1.6 megapascals. So at 1.6 megapascals, water is going to boil at 201 degrees Celsius, and we're down here at 500. So state 2 is 0.22029. So V2 is 0.22029. That's based on P2 and T2, which we have over here. P1 and T1 here, P2 and T2 there. If it helps you write those, right? Seriously, do not skimp on what helps you. If it helps you to write these, do it. For a lot of people, you get to classes at this level, a lot of people have probably been able to do algebra in their head all their lives, and they're always, they never really had to think too much about it. And now you start encountering classes where we're actually challenging you. And that's not true of everybody. Some people, you've learned how to work through this because you've been challenged your whole life, and that's good. Some people haven't, so it's a bit of a shock sometimes. Yeah, there's a lot of steps, and we're not even halfway done yet. That's okay. Seriously, that's not a problem. All right, Steve, what the heck are we trying to do again? Well, remember I said early on, you don't have to write the problem statement verbatim. You just need to write down what is it that you're looking for. Okay, we're looking for the boundary work. How do we find the boundary work? Well, I need pressure as a function of volume. Well, I know pressure is a function of volume, but I need C and N to get there. Okay, so we did some algebra, and we figured out N is equal to these quantities. And now I have these quantities. Now I have volumes, I knew pressures. So now I've got this expression down here. And we're going to say that N is equal to the natural log of, we said, V2, that is 0.22029, divided by 0.24674, divided by the natural log of P1, so it's the natural log of P1, we said was 2 megapascals. And by the way, when it's like this, where you got the same units on top and bottom, you could write those. You wouldn't have to. Okay. Don't take the log. Well, if you take the logarithm of weird units, the units that don't match, you're going to have to carry those. It's going to be the natural log of those units. But in this case, it's the same units top and bottom, so it's going to be okay. All right. So let's see here. Let's make sure I'm not glaring on the screen here. All right. Good. Okay. So I need to take. How am I going to do this? Let's do the bottom first. So I'm going to do 2 divided by 1.6. I'm going to take the natural log of that quantity. I'm going to invert that and multiply that to the top. So we'll put the top in parentheses. Put one more parentheses there, so 0.22029 divided by 0.24674. Close parentheses. I'm going to take the natural log of that quantity, close parentheses, and then hit equal. Did I do that right? Normally I get about -2. Why am I getting -0.5? Have I inverted something? Okay, I'm going to pause here. I'm going to double check my algebra, because normally I get a -2. So let me double check my algebra and I'll be right back.